it's taking me a number of years, literally, to realize that there is this war raging around me, okay, and it's paradigm war, and it's between the two camps. I can roughly label them: the science camp and the humanities camp. In the science camp, research draws on causal and correlational methodologies. The data comes from randomized controlled trials, quasi or natural experiments, exploratory studies, evaluation studies, and those would involve interviewing of participants, focus groups, and the data will be analyzed qualitatively. So my point being is that in this camp, both quantitative and qualitative analysis is used in conjunction. So as such, the findings are aiming to be generalizable, they're aiming for replicability, and the assertions of validity and reliability is an absolute must to get anything published in the peer-reviewed journals. Whereas in the humanities camp, qualitative research methodology is used, and it's based on an interpretive framework. So the data comes from interviews, focus groups, observations of classrooms, student written work, video recordings, similar things that the other camp is using, but the difference is this camp pledges allegiance to the postmodernist paradigm. Okay, and it's taken me a while to understand what this means. Okay, under the postmodernism paradigm, social reality is viewed as diverse and pluralistic. So that means that depending on your worldview, you can analyze the same set of data and come up with different conclusions. And that is not only accepted, that is celebrated in this paradigm. So, and obviously, that the people working in this paradigm, they express heavy skepticism of the value of the scientific method that to be used in educational research. As such, the research is not aiming to be generalizable, it's not aiming to be replicable, because two researchers can analyze the same data and their subjective opinion on what it means will be accepted. It could be different, it doesn't matter, everything is valued and accepted. Validity and reliability, those terms are used, but they are understood differently. So, while diversity in research methods is usually a great thing, right? It's valuable. However, the benefits emerge only when there is active interaction between different perspectives. We need to have cross-pollination of ideas for the benefits to emerge. Here's another realization. This is not happening anymore. So the two camps have fallen out and parted ways about 25, 30 years ago, depending on the country you're in. But it's happened across most English-speaking developed countries. And that is problematic, of course, and the reluctance to interact that comes from the humanities camp. Okay? And the most common question I hear from the people working in that camp is that what is the point of trying to do research in educational context when there's too many variables to control for? It makes no sense. We just can't do it. It's too hard. And then to that I'd say, what about medicine? There's so many variables there, and the variables that we know many, but we also, there are variables that are unknown, and like unknown unknowns. Yeah? And yet, the major progress in medicine has happened not too long ago, about 150 years ago, when the medicine has embraced the scientific method for research. Right? I mean, we've come a long way from using bloodletting with leeches to fix every problem, right? Yeah. It's only 150 years ago it's happened. Right, so the absence of one overarching accepted research method in the humanities paradigm results in a proliferation of research methods. Okay? And I'll give you an example because I bet you have no idea what I'm talking about. An example, a group of esteemed academics, New Zealand-based academics, recently unveiled a novel methodology 2 or 3 years ago. It is called poetic inquiry. Okay, so in case you don't, poetic inquiry, and that is a methodology specifically developed for undertaking research in mathematics education. So what I've went to many talks by this group of researchers, so I will describe you how it's done. So the researchers interview their students who are teachers in training, and they ask them questions such as, what are your feelings about mathematics? And the teachers would say something that is recorded, so they'll talk about the anxieties and the negative feelings and blah, blah, blah. And so that data will be transcribed, and then the transcripts of the data will be read by those researchers, and then they'll go away and write a poem. And a poem is a research outcome of this analysis. And to be honest, I love a good poem. I really appreciate the aesthetics of a beautifully written piece of poetry, but I do question its utility for policy and practice recommendations. On the other hand, attending mathematics education conference is so much more fun. I think we should take it up a notch. We should introduce a singing inquiry and maybe a dancing inquiry, right? Then we'll sell out all the conferences. But anyway, so another realization. My concerns are not mostly shared by other researchers. All right? In fact, the humanities camp has been growing and expanding over the last 40 years, much, much faster than the other camp. And by my rough estimate, it comprises over 80% of active educational researchers in most English-speaking developed countries. In New Zealand, that is even worse. It's well over 90%, 90%, okay? The humanities camp. I will offer some explanations later. But the growth of this paradigm has been accelerated by a mass exodus of scientific researchers from basically the main mass education journals due to epistemic bias, which was recently, well, 5 years ago, was published and now considered to be a seminal scoping review of the field by Matthew Inglis and Colin Foster from Loughborough University. They looked through all publications in the last 50 years in the top journals of the field, and they came to this conclusion. So the science camp was essentially marginalized and driven out of the mathematics education journals. Right. I've spent many sleepless nights thinking about it and trying to explain what has happened. I can offer you two plausible explanations. Okay. Explanation one. In most English-speaking countries, the teacher training colleges used to be separate from the universities. Okay? Starting from the US around mid-1980s, those teacher training colleges were forced to amalgamate with the universities. And the other English-speaking countries followed suit just a bit later. New Zealand was one of the last ones. The University of Auckland set up the education faculty in the mid-1990s. or later, some universities even later. All right, so what's happened in this process? In the past, teachers were trained by very, very good teachers, but those exceptional teachers were not hired to be researchers. They didn't sign up for it. Suddenly, they were forced to become researchers. They were asked to do PhDs or leave. So the ones who did their PhDs did it under the supervision of academics from the humanities, because under the amalgamation, the education departments were set up under the humanities, mostly, humanities and arts, okay, before they expanded to become their own faculties. So that has established a culture of research, and that has cemented the culture of research in English-speaking countries. Notably, this is not the case in other developed non-English-speaking countries. Germany, Sweden, the Netherlands, and many others, they never had teacher training colleges separate from the universities. The teachers were always trained at universities, and that's the difference. Coincidentally or not, those are the countries that experience well-functioning educational systems now, which is not the case for the English-speaking educational systems. Right, moving on to the next slide. Okay, so I'm going to use this opportunity to make a strong case for the stopping of this paradigm war. And I will do it by arguing for the benefits of the two camps joining together. How do we advance the discipline? How do we build the tower of insight? I suggest that we need to leverage insights from both qualitative and quantitative research, absolutely. And to illustrate the advancement of discipline out for this controversial, to some topic, I will use a somewhat controversial building, Burj Khalifa, okay? Yeah. So, how do we advance a discipline? We first build a strong foundation for a building. How do we build Burj Khalifa? We need a foundation. So the foundation is built from exploratory case studies. We don't know much at all. We need exploration. So we can't really do much in terms of quantitative research anyway. So we need to identify new areas of inquiry. We need to describe new constructs. We need to build that solid basement, okay? Then we need to do theoretical consolidation. We need to take all these separate case studies and unify them by some theory development. That is also qualitative work. And so you have got this frame emerging. You build a frame and the tower's going up, right? Then, this is the controversial step. We need to complete the level. We need to, instead of the frame, we need to actually build something solid there. And that is done using scientific method, all right? We need to test the theory. If your theory is any good, then your theory will be able to predict something about educational context. You change this, this will happen. You change this, this will happen, okay? If your theory cannot predict that, then think harder. That means your theory is not developed enough. And then once you have an objective to test the theory, then you can use available methods from statistics, modeling, whatnot. And then advance to the next level. Once you know you've got solid building that you built, you can put another level on top. It's not going to collapse. And so, advancing to the next level, you go back to qualitative research. You need to check the ecological validity. What you've been thinking and testing in the lab might not translate into real educational context. In the classrooms, it might work differently. You might discover some other variables that you didn't control for. So that's, again, a qualitative analysis. And you keep on doing it. You build your tower of insight. Okay? But you do it so that it's solid and it doesn't collapse like a house of cards. Okay? So, the humanities camp is mostly working in the building of the basement of this tower of insight. Okay? So they come up with, they produce a lot of useful insights in terms of exploratory case studies, right? And a lot of theories being built, but there is no mechanism to discard bad ideas. There's no mechanism by which they will reject some theories and say, okay, this is how we progress. So it's basically a building a big, big, big diverse basement and not going up to actually seek insights. So, in terms of policy and practice recommendations, you can offer policy and practice recommendations at any concrete level of the tower. It has to be solid, okay? Unfortunately, really regrettably, what's happening is that the policy recommendations are offered from the basement. And I can attest to this as a reviewer, referee for many, many mathematics education journals. This is happening a lot, okay? I review many papers that are purely qualitative, no generalizability, and in the conclusions, there are policy and practice recommendations. And if you want to take one thing out of this talk, this is, in my mind, the main problem that caused all the declines in most English-speaking developed countries. That the policy and practice recommendations are offered from the basement level. Right, as you can imagine, using this approach, mistakes were made. Guess what? We can be proud. New Zealand is punching above its weight in this. Actually, the impact on the world is absolutely outstanding. All right, briefly mentioning learning styles theory. Many of you who have gone through the New Zealand education system would have been classified as one of the 4 types: visual learner, auditory learner, reader, kinesthetic, whatnot. If your math teacher classifies you as a kinesthetic learner, that means you learn math best by touching and working with objects. Okay? So this theory was so grand, it came out, I'm not going to mention the university, but it came out and supported by basically from New Zealand. Okay? And it spread like wildfires around the English-speaking world, to the point that then the science camp, of course, looks at this like, okay, this is not right, and then they drop everything, start testing it, and then they debunk it, but nobody listens to them because the camps are separated. And then, so the science camp's been debunking this for 20 years, and it wasn't enough, and I was pleased to see finally in the Nature this year, a proper randomized controlled trials stating it is detrimental to learners. Detrimental, stop doing this. Despite that, in more than half of the US states, teachers in training have to study learning styles theory to pass the qualifying exams, licensing exams now. The data is October 2023. Okay? This is how pervasive those ideas are and how influential the humanities is in terms of policy and practice. This is like humor for you. I found it on the internet when the Nature article popped up. Look at the last one. Taco. I'm a taco learner. I only learn if I'm eating a taco. Guess what? The science camp hasn't tested this yet, so we don't know. It might be true. Right? Yeah, we just need to, for the science camp to drop everything and start testing this. Right. The biggie, right, this didn't concern me, okay? But the biggie that is really concerning to me and to all of the mathematics educators is this: constructivist teaching fallacy. This is a direct consequence of the paradigm wars. And that was due to the wrong assumptions that were made about the role of memory in learning and the role of expert explanations provided by teachers. And that was due to just the humanities camps did not know about the insights from decades of research in cognitive sciences. I will tell you a bit more what I mean by that. I'll illustrate it. Okay, crash course in a minute. How do people learn? So here is a diagram of a model of human cognitive architecture. Okay. So we've got three compartments. You've got sensory memory, you've got working memory, and you've got long-term memory. Okay. So the sensory memory stores information that comes out from your sensors, like the eyes and the ears and other sensors. Then, by a process of selection, by attention, some information ends up in the working memory to be organized and processed. And then once it's organized and processed, some of it gets encoded into the long-term memory, which is your long-term storage of knowledge and skills. And you can think of it as the knowledge and skills are stored in the hierarchical network called schemas. Okay. So you mathematicians will have very elaborate, very complex schemas in your long-term memory pertaining to your domain of expertise. Okay? They'll be well connected and well organized, so they can easily retract them when the cue comes up. Okay? So there is no known capacity limits it doesn't seem to have any limits, the long-term memory. We can store as much information as we get. However, there is a huge limitation in the working memory. So this is only limited to 7 plus or minus 2 separate elements of information at a time. So there's no superhumans. We all have this limitation. You can only juggle separate, distinct elements of information if they're not connected by a schema at a time. Okay? And then if you have more to juggle, you go into cognitive overload. You cannot think anymore. So the process of learning requires working memory to be actively engaged in order to organize the information and in order to encode into the long-term memory. But that has limitations, right? So the biggest breakthrough in the cognitive sciences came when they showed that the limitations of working memory effectively disappear when you pull out the information from the long-term memory. So the 7 plus or minus 2 limitation disappears. You can pull out the schemas from your long-term memory, as many as you want, okay? That 7 plus or minus 2 does not count those schemas. So, okay, I'll give you an actual illustration to exemplify. Imagine if someone tells you their phone number and asks you to memorize it. Okay, wake up. I'm actually gonna do it to you, okay? I'm gonna give you 10 digits, right? And I will show you them to you for like 5 seconds, and then I'll ask you whether or not you remember them. Ready? Okay, give you 9 seconds. If you remember, please raise your hand. Oh, good. You're happy. Okay. Right. Good. Now try to add each consecutive pair of numbers in your head. And tell me. Come on. Who is talking? I can't see. Raise your hand. Yeah, go.
1, 5, 10, 7.
No. You need to add 2 consecutive digits.
Okay.
0, 1?
0, 1 is 1, 1, 4 is 5, so that's what he's doing.
Oh, sorry. Yeah, come again?
I forgot.
13, 10, 7, 8, then 7, 8, and 9.
You rely on collective knowledge. So basically, if you could do it, 10 is bigger than 7 plus or minus 2. So your working memory is overloaded. You can't juggle those 10 digits in your head and adding them. Okay? And so the only way you can do it is to recognize there is a pattern to it. And if you know there are squares of integers from 0 to 6, That's your schema from the long-term memory that you're pulling out. And then you can go back to that schema. You can actually do that in your head. Okay? And so that's how we think. The point I'm trying to make here is that in order for you to think, you need to develop more and more schemas in your long-term memory. It makes your thinking a lot more efficient and easy. And when people talk about critical thinking, you cannot think critically about anything if you don't have any schemas in your long-term memory. By extension, I'm not going to take time to talk about it. Those now proponents of why do we need to learn anything anymore? We've got the internet, we've got ChatGPT. No, because the information there has to pass through your working memory. And that's novel information. So that is a novel element. It's one of the 7 plus or minus 2. So your memory will be overloaded. You need to put that memory, to organize it into your long-term memory in order to integrate it in your thinking. Right. As a result of the paradigm wars, this been erected, the wrong dichotomy has been erected for decades. And the wrong dichotomy is roughly summarized: rote learning versus learning with understanding. In the last 3 decades, long-term memory played almost no role in any instructional recommendations. Okay? Rote learning has become a bad word. So it's based on the wrong assumption that long-term memory plays minimal or no role in learning with understanding, which I have to probably 1 minute of explanation, probably on my side. But you cannot learn with understanding if you don't have anything in long-term memory. You need to link the new knowledge to the existing schemas in your long-term memory in order to organize this information in a hierarchical structure. All right, so as a result, major educational approaches such as constructivist teaching, discovery learning, all these approaches have something in common. They de-emphasize the role of long-term memory. And by extension, they devalue explicit teaching. The idea of a teacher standing in front of a classroom, imparting knowledge to be memorized, became an offensive, repressive idea to many educational researchers and leaders for many decades. A very famous professor, educational psychologist, Richard Mayer, wrote a review almost 20 years ago, titled, "Should there be a 3 strikes rule against pure discovery learning?" He made a striking observation. In each decade, since the 50s, after empirical studies provided solid evidence that the then popular unguided approach did not work, a similar approach soon popped up, but under a different name. And the cycle has been repeating itself ever since. We started with the discovery learning, then it's been made as experimental learning, then it became problem-based learning, then now it's called inquiry-based learning. It's reason reincarnation. Now, inquiry-based learning is a big thing to many mathematicians in the US right now. In the last 10 years, major efforts have been done to instill this method across the US. There was huge millions and millions of NSF funding to support the development of networks, dissemination, blah, blah, blah. It is huge. The last time I've checked, the network of the practitioners who commit to inquiry-based learning had over 800 people that you can just see on the internet. And it is really, the ideas, when I first heard them, I thought, gosh, this is so compelling. You can learn in a fun way by inquiry instead of listening to some boring math professor like I learned. Yeah. And so I was sold until I started actually reading the literature from the science camp. And it was a very beneficial thing for me to do. I did it with Heiko Dietrich, a mathematician from Monash University. He was very concerned, just as me, so we joined forces and did it over a few months. We've read over 100 publications and books on the topic, and we published a scoping review specifically about mathematics education at tertiary level. And we presented an argument to synthesize everything that's been done using human cognitive architecture to say that exploration of complex phenomena for novices with minimal guidance is likely to impose heavy loads on working memory, thus resulting in detrimental learning outcomes. We also said that there is no evidence to support a common claim from the proponents of that method that to learn using the inquiries kind of results in a deeper learning. There's no evidence whatsoever for this. And there's no evidence that it's more equitable. And that camp, the proponents, that's what they're saying, it's more equitable. Actually, there's evidence to the opposite claim, that it's less equitable. That is my case, you can read it. So we see that a quality instructional explanation is highly beneficial because, going back to the human cognitive architecture, very good teachers, what they use both visual and auditory channels to reduce the processing load of the working memory. So there's, it's details, but there are two different ways for the information to come in. And that's what we naturally do, right? When we teach maths, we usually write on a board diagrams and we talk. We naturally evolve to optimize this process. Also, explanations focusing on concepts and principles, which good teachers, that's what we do, right? They direct the attention. So that means directing the attention to the important parts means you're telling your learners what information to select to be in the working memory to be organized. And then you also cue relevant schemas to be brought up into the working memory so that the organization of the new information happens more efficiently. Okay, so another big realization. There is notable scarcity of research on explanation quality. It became a taboo. No one's researching this, okay? And it's due to paradigm wars. So I and my colleagues from Rutgers and Loughborough University, Matthew and Pablo, we started this research program not too long ago. We published a couple of papers and we're going to continue this program. But we feel like, wow, we're starting a whole new field here because nothing's been done. Right. How did it happen? What mechanisms enable this madness? I thought about this and I realized that I think the biggest factor was that constructivist teaching was labeled as progressive education. And the many people who align with progressive politics felt obliged to offer unconditional support for this. And the arguments they were making to link it to by this one word, progressive, were compelling enough. I digged through the history of this when I was writing that scoping review. Guess what? There's some really far-right educational experts who were really keen on the same approach, such as the Minister of Education of Mussolini government, as an example. They basically were using this pedagogical approach and many more. And then quite a few Marxists really criticized this approach because of its individualistic nature. There is no reason for this approach to mark to a point on the political spectrum whatsoever. It's wrong, it's unwarranted. But I think that's what's happened because it was labeled as progressive education. The progressivists just offered support and propelled it. Right, brief overview on the important things that I've recently myself discovered, which I wished I knew. Cognitive sciences. we've known for 140 years how we learn and how we forget. Here's a typical forgetting curve. The implications for us is that students forget more than 50% of the new information that was presented to them in lecture within 1 hour. And that's normal. We're the same. Okay? If it's completely novel, you don't have pre-existing long-term schemas in your mind, there's nothing for them to attach to, it's gone within an hour. Okay? So, but the good news, we can reverse the forgetting curve. We've also known this for a very long time. Okay? So the spacing effect is a real thing, very well documented and tested. So if you introduce maintenance rehearsal to revisit the information, you can actually ensure that you will remember it for a very long time, for your whole life, if you want. And the best, most optimal way to do it is to introduce your repetitions, so maintenance rehearsal, revise, and space it out, make the intervals larger and larger. That's the most effective way, okay? And we should keep that in mind when we're designing our courses, our structural courses. All right, the testing effect, also known as the retrieval practice effect. Very, very important effect to know. And we have very strong evidence from a myriad of randomized controlled trials to say that long-term memory is increased when part of the learning is devoted to active retrieving of information from your memory. We've known this for 100 years. Okay? I haven't heard of it until I actually read some literature 3 years ago. Nobody told me. Okay, so the implications for us, we need to design learning environments to support all these effects. We need to support space retrieval practice. So, one important point. Tests and exams are not just summative assessments. I hear it all the time from higher ups who are like trying to cancel exams and tests. They're actually useful for learning. Okay? So, the randomized control experiment randomly selected 2 groups of learners. One group sits a test, the other group works on the same problems, no test conditions. This group learns better. Okay? Replicated numerous times in all contexts imaginable. The learning is enhanced under the testing and exam conditions. Closed book exams are conducive for retrieval practice. The students prepare differently. If there's an open book exam, they know that they don't need to memorize anything, right? So they prepare differently. They do not engage in retrieval practice during their preparation. So, coming out of COVID, I know. If we decide to have the entire mathematics major open book, our learners will be disadvantaged at the end. They will know less. Okay, I have to confess I do 1-page cheat sheet to just keep the student happy coming out of COVID, but it's, yeah, that is what it is. Another thing is to improve the learning environments. Frequent low-stake quizzes, easy way to reverse the forgetting curve. So if you ask your students to do something very shortly, after the new information has been presented to them, that's your first maintenance rehearsal, okay? The 50% of the information will not be gone anymore, okay? Just ask them to do it. It's easy now with the technology. And we've written about it, and I know some people from Otago are using it, and some people from Canterbury are using it as well, because they came to my talks in 2017-16. Anyway, the other realization that I came up to is that if we want to answer big questions of the field, how do we optimize learning at university, or how do we optimize it? You cannot just study cognition. You have to account for other psychological phenomena that interact with cognition, right? We need to also look at things like motivation, self-efficacy, all their beliefs, all their achievement emotions, and how those things interact with the cognition. Because they interact through engagement or disengagement, I should say. And I was delighted to discover there is this huge body of knowledge developed to help me. Okay, it's from educational psychology, decades of wisdom. All right, so they use psychometrics, and psychometrics combine statistical and mathematical tools with hypothetical deductive science to identify and measure those fuzzy constructs, such as confidence, self-efficacy, motivation, achievement emotions. You can actually operationalize them and come up with good ways to measure those things. Okay? Unbelievable, but I was just so happy to discover this field. So they use mimic models. So students are presented with questionnaires, items, trying to discern their feelings and thoughts about themselves and their motivations and things and their behaviors. And then their responses are assumed to be caused by two sources. One is the underlying construct that we're trying to study, operationalize, and the other source is random unexplained factors, the error. Right? So those models do account for distraction, inattention, lack of effort. It's all accounted for in those models. We assume that people sometimes don't hear when they tick wrong boxes on questionnaires. It is assumed, okay? Right, so mimic models remove this random source of variance from the latent constructs, and then as such, it is possible to estimate the relationship and their strengths from all these constructs that we theorize and their relations to actual learning outcomes that we can actually measure. Right, you're probably familiar with some of those models. It's all types of factor analysis, principal component analysis, exploratory, confirmatory factor analysis, structural equation models. So those are the methods that they used. And I have to say, I have to mention the work of my amazing PhD student, now Dr. Caitlin Riegel. She's used all this machinery to understand the assessment-specific affective constructs in mathematics education. And I won't say much more. You can read it in your 200-something plus pages of your thesis, which was based on 5 publications. And this one, she actually developed her own instrument, which is a hard thing to do, and validated it. And it's been published in the Quartile 1 generalist journal. It's sort of in late in 2022, already been cited 5 times. So, these are the little pictures that she used. So this is sort of cross-legged model, structural equation modeling. So you have all these correlations going on between different constructs. You can study those things, make sense of it. You can use cluster analysis, put all these fuzzy variables and classify your students in terms of their experiences of the learning environments. You take into account their self-efficacy beliefs, their achievement emotions, how they feel about stress, whether or not it's debilitating, enhancing, all these things you can study rigorously, scientifically. Anyway, added my students to be mentioned, Sang-Myung Kim, who's here. He's working at the intersection of cognitive psychology and educational psychology in the mathematics context. So trying to look at the very atomic level of math sense making in different educational settings, whiteboard tutorials versus desk tutorials, flipped classroom with Yaron, and class quizzes with Melissa. And Tanya and Huai Gao are crunching big data. They're digging into teams. Tanya is looking at what has happened to the educational system. There are some things we can deduce looking at longitudinal data from teams over the last 20 years. We have that data. And Hawaii is looking at protective factors to enable girls to continue with STEM tertiary study. Right. I want to finish with acknowledging a huge contribution of the NZMS members to the mathematics education that's been happening recently. And some of you might know that Royal Society Te Akarangi asked for the Royal Society was asked to create an expert advisory panel to investigate what's happening with the maths achievement in the country. And they've asked Gavin Martin to chair that panel. So the panel consisted of mathematicians, math education people, economists, statisticians. Rua Murray's done a lot of work for that panel. It was a major piece of work, and they uncovered decades-long ongoing decline in math achievement. That's not what the ministry was kind of asking them to do, but they did it nonetheless. Thank you. Gavin Martin chaired this panel, and he asked, so somehow I was asked to be the external expert reviewer at the end, so I had to engage with whatever they uncovered as well. So there's a quick graph of that's in the report actually. So what you see here is the data from PISA in our big large-scale assessment, international assessment. So what you see here, New Zealand is in the green color in the middle. Here, sliding down, sliding down. And Australia, dark blue, also sliding very close in tandem with New Zealand. And that is to compare with relative stability of the light blue, which is OECD average. Okay. Singapore, the top, is in the league of its own and has been. And Japan is doing well. Canada also sliding down on the same slide as us. England, so the UK came from the US, right? So they've been down for a while. Then it hit the UK. UK is waking up first. You see some changes. They invested hugely in the science camp research at 2010, 2012. Things been improving ever since. So overall, there's a system failure over decades in the New Zealand educational context. And I was reading that report, and I'm thinking this is the direct consequence of the paradigm wars. In my mind, this is exactly the reason, the main reason. So I thought, well, Gavin and Rua spent half a year digging through this. Someone's gonna keep on going, right? We can't just not do anything. And I'm the head of the mathematics education unit in the Faculty of Science. Who else is going to do it, right? So one of the recommendations from the panel is to improve leadership in the country, to build educational research capacity and promote data-driven research to inform policy and practice. That's what they said, okay? So what I did since 2021, I actually undertook a scoping review of the existing research capacity in education in the country. It was hard and painful. And I also assessed very careful the capability of the main educational research association, which is called the New Zealand Association for Educational Research, NZIARE. That is a very important association because it connects researchers with the government agencies such as the Ministry of Education and the New Zealand Council for Research in Education. I went to their conferences for the last 3 years. And guess what? What I discovered? The science camp is not there. It doesn't come to those conferences. It goes overseas. It just doesn't engage anymore. So, said nicely, I identified a gap to promote the establishment of a special interest group within NZIARE dedicated to quantitative studies in education. And by this I mean plus mixed methods. We couldn't say the science camp because, yeah, it's loaded. So we just said that, quantitative studies in education. And I will finish to say, proudly, it's been launched this year in May, and looks like it is successful. I have to acknowledge my partners in crime. Valerie Sattardi from the University of Canterbury, she's a co-convener, and Robin Cagle from the Ministry of Education. Now, Robin is a chief policy advisor, and she actually came to me. and she's been just elected the president of Enzari for 2 years. It's gonna happen. Anyway, so this is the web presence of ASIC. The first online panel discussion we had in September attracted 140 people attending. And at the recent first face-to-face meeting 2 weeks ago, we had 17 research teams coming together for the first time on New Zealand soil and collaborating, networking, and talking about this very big issue. So we are enthusiastic and we're going to persevere. The next 2 years are probably crucial, whether or not it's going to fold or will grow. But I want to finish to say thank you. And remember, we need your support, okay? Because I need to have your backs, because where else would I get support from? Thank you.